Hello. The official start. I'm going to share my screen. Hello, everyone. My name is Marta, and I'm super excited to be a part of this conference, DevDays Europe. I am a huge fan of progressive web apps and Angular, and today I will tell you how you can implement progressive web apps in Angular with offline-first approach. And if you're a fan of tech conferences, you probably heard about this topic because in the last recent years, it was really hot trend in web development. And even a basics will be enough to join this presentation. But the most important that you need to know before I start presenting the topic, this is the factor that tells you if it's worth it to progressively enhance your app into progressive web app. And this factor, this is character of your data in your app. And because if you have static websites that you can easily cache, it's not so difficult to create an offline app. But if you have more interactions between client and server, your data is more dynamic, this is more challenging. And it's quite challenging to create effectively working offline app and also to keep data fresh. And today I will tell you about one solution in Angular that allows you to store data locally on the front-end side and also synchronize it with the backend automatically. And now let me introduce myself. My name is Marta Wisniewska. I'm from Poland. I live in Warsaw. And I'm Google developer expert in Angular and web technologies. I work as a front-end developer, and I love all things about tech, but especially Angular, web performance, progressive web apps, and so on. I'm co-creator of open source project called PWA Fire. If you want to get some knowledge about PWA, you want to start your journey with this technology, you can find us on Twitter or visit our website. And besides technology, I love coffee, sport, and community. And if you want to stay in touch, if you will have any questions after the presentation, you can find me on Twitter with this username. And this is the plan for us for today. And I will start with introduction to offline first approach. I will tell you what in general it means, what are the golden rules, and what are the advantages of this approach. Then I will tell you about the offline storages, possible options to store data locally on the client side in the browsers. Next, I will tell you about PouchDB, that is a wrapper for index database. I will tell you how I use it in my app that I will present you later. Next, I will present you how you can practice this approach for case of Angular, but also you will be able to follow this in any other frameworks. If you will see the solution, how I use it, what I used on the front end and on the backend side, then you will be able to customize it on your own. And next, I will switch to the optional model that is crucial if we're talking about progressive web apps and performance, improving performance for web apps. And last but not least, I will tell you about offline first apps. I will show you examples, apps that were created with this approach, with PouchDB, that are currently in production. You can just test and verify how they works. And my purpose for today, for this presentation, is to help you understand the offline first, but also I want to show you how a huge impact developers have on human lives. And I think that we quite often feel like the frog from the picture, that something happens too many times to us, again and again, and regardless of what we do you know that? Or maybe sometimes it's not too bad, but then it is, and you feel totally unstable, dangerously unstable, like, I don't know, like this. Or even a simple, small thing totally frustrates you. Typical moving, loading things, right? Do you know that? As you can see, this stress, negative energy have a huge impact on us. And regarding to this, a bunch of scientists were working on human brains and find solution how to make people happier. And the results were totally surprising because they discovered that the only one way to make people happier is to create fast and stable apps and use offline first. So let's talk about it. So offline first in general means that offline state is not an error condition. This is additional state to handle in your app. And I suppose that you already heard about it and use it, but maybe not in web apps, but more in desktop apps or native apps. And I will give you some examples. For example, if you have Spotify, the native version, and you're offline, you're not able to track music. But for example, you're still able to edit playlists, to stuff like that, and your app's still working. And another case for desktop apps. If you use Slack and you're offline, you're not able to send a message, but your app's still working, and you're informed about the network state while you're offline. So it's great because of user experience. But what we do in web apps, so we store our data locally on the front end side, we cache it and show that to the user, and at certain times we synchronize it with the backend, we fetch new data and we show new data. And from developer's perspective, you should write your app and assume that you don't have internet access at all. And the more you can render without the network connection, the better for you. But of course, this app probably won't work the same way like online. But we should try to do as many as we can in this offline state. And if it works, then we're ready to add more network functionalities and we can make it more powerful while it's online. And there's a lot of advantages of this approach. And the first one is quite obvious that you can actually build apps that work offline, but there's more. You can, for example, create faster user interfaces because your CRUD operations, create, read, update, and delete, are moved rather locally than remotely. And also in this approach, we quite often apply the app shell model that allows you to return the view of your app to your user very quickly. It's eliminating any potential time to first byte issues, and it also has good impact on user experience. And another thing, if we're talking about user experience, it is the possibility to display the network state for your apps and inform about different states. And from the other perspective, we can fetch network requests periodically versus all the time, so we can save bandwidth and also improve battery life of your device. And here, there are golden rules of offline first. So the first one is that we should use local data whenever is possible. And we can use XML HTTP request to get this data and save it locally. And today I will tell you in the next slides what are the possible options to store your data in a browser. And please remember that we don't keep sensitive data of your user, for example, passwords. The second point, we should separate user interface from its data. It allows you to improve the app design and also will ease some tasks to enable offline usages. And to do that, we can use some MVC frameworks. They are really useful just to separate this logic from the view. And next point, we should assume that app can be closed at any time. And we can save state of your app locally and remotely if it's possible to allow the users to pick up wherever they left off. And last but not least, we should be careful about tests. And we should test both common and tricky scenario. And we have great tools that allows you to test your app in Chrome and developer tools. We should test how your app behave when you change the network connection. and also how it behave when you open it for the first time. So yeah, you should really take care about this testing, and please remember about opening your app in private mode to test it, and yeah, that are the main rules. And now I want to tell you about offline storages options that allows you to store data in a browser. And there are basic options, and I suppose that you already know that. So basics, this is session storage that allows you to store data locally in a browser for the duration of page session. And local storage allows you to store data even if you close and reopen your browser. And these storages are quite common, but also have some downsides. For example, you need to serialize and deserialize data because you can only store strings. They're synchronous, which means that they can block your app. They don't support web workers. And WebSQL is a bit better because it's asynchronous, so it's based on callbacks, but also has no support for web workers, and there's no good support if you're talking about web browsers. So I will tell you in a moment. So here you can see that it's supported by Chrome-powered browsers, just Chrome, Edge, and Opera, but it doesn't work, for example, in Safari and Firefox and in Internet Explorer. But if we take a look at the other options I presented to you, I told you before, so this is local storage, has great support. All modern browsers will work with this storage, and this is the same for session storage. So let's switch our focus to alternatives that work with web worker. And the first one is File System API. And File System API also is asynchronous. It's based on callbacks. But to be honest, it doesn't have much power outside of Chrome, and is sandboxed, which means that you can't get native file access. And File API is quite similar, and it help you to store files in a browser, and for example includes interfaces like File API, File List API, Blob API, and so on. But from practical perspective, in offline first and progressive web apps, we use index database and cache API. And index database, this is NoSQL document database that allows you to store pairs of key and value. And it's great for structured data, but it can store different types of data, strings, JSONs, blobs, and so on. It has great support if you're talking about web browsers. But Cache API were created to allow service worker to catch and to store network requests and responses. And these requests and responses can contain any kind of data that can be transferred over HTTP. And what we do in offline first is that our static data we typically store in Cache API, so that are all resources that are necessary to load your app while offline. But for more dynamic cases, we use index database. And another rule, this is that URL data go into cache, but non-URL data goes into index database. And here you can also find the browser support for these solutions. So index database has great support, as you can see. And Cache API only doesn't work with Internet Explorer. So today I will tell you about not raw index database, but I want to show you more, let's say, developer-friendly solutions, because now in our frameworks and tools libraries, we have many supports for progressive web apps. And here you can find JavaScript libraries that are wrappers for index database. And today I will focus on PouchDB, and I will show you how you can use it. But you can also find others. This is, for example, Dexy.js, JSStore, or Local Forge, so you can also try them. And it's good to know about storage limits. And in general, in Chrome and Firefox, you can store data in a browser until quota is reached, and you can find how much quota is already used by Quota Management API. For Safari, this is a limit for the mobile browser. This is 50 megabytes, but also you can find another like Internet Explorer and Edge. In Internet Explorer, you can find 250 megabytes. For Edge, this depends on volume size. And I highly recommend you to understand what you can store in different types of data just to follow a good example of progressive web app. Open developer tools in Chrome and just check what is stored in different types of these storages. And here you can find example for Twitter, because I think Twitter is one of the best, the most popular progressive web apps, and I highly recommend you to check it on this web app. And now I want to tell you about PouchDB. This is wrapper for index database, and this is open source JavaScript library that allows you to store data locally and synchronize it with the backend automatically. And it's great because you can use it everywhere where JavaScript runs. So you can use it in my example in Angular, but also with any hybrid apps, for example, with PhoneGap. You can use with desktop apps with Electron and any Node.js and so on. And this is my architecture that I created in my offline first app. So on the front-end side, I will have frameworks, Angular, and PouchDB, where I will store data locally on the client side. On the backend side, I have CodeDB, that will be my server, where I will store data also remotely. And CloudDB is quite similar to MongoDB. If I could compare these both, I think they are really similar. And what we do in our web app, that we send our data to PouchDB, we replicate it, synchronize it by configuring the type of replication. And then if anything changes on the backend side, then it will push changes to the front end. And on the front end side, we will subscribe to these changes and just fetch this new data and typically refresh the view of your app. So let's time for practice how you can use it in Angular. So if you want to use Angular and implement progressive web app, you should apply this command. This is ng-add Angular PWA. And if you will do that, then you will see some new files that are necessary to progressively enhance your app into PWA. So you will get, for example, web manifest file, icons for your progressive web app. You will see imports for service worker. But the most important, this is the first file, this is configuration for Angular service worker. And this look this way. So you will see the configuration, and it's just instruction for your cache, how to cache some files. What is the mode for this caching, and what are the or specific files, or just, for example, as you can see, you can list them in other ways like this with abbreviations. So how I integrated Angular and PouchDB. So step 0, incrementation typical for programmers. So I had to install and import dependencies. And I needed PouchDB or PouchDB browser. And in this case, I used PouchDB browser because it was just a smaller package, and I just needed, because PouchDB is a huge and you can use for different apps. But PouchDB browser is typical for web apps enough, so I use this one. It also is good to have the PouchDB server to run it locally. And if you have imported and installed your dependencies, you can import them in files where you will use it. And in my case, I use it in a service, and I do that in this way. And step first, you have to create database. And here you can see the example that you have to type new PouchDB, and you need also to add the name for your local database. Then we will hook it up with backend for replication. So I will use method sync. I need to add as parameter my remote database that I will configure, let's say previously or define previously. And I also configure the type of replication. And here you can see these two parameters that actually means that you have bidirectional replication for this case for my two databases. And then you're ready to implement CRUD operations on the front-end side. So if you have ever used document databases, you will do it in similar way. So I will just have a few methods that allows me to manage my data in my local database and integrate it with interactions in my app. And then I will subscribe to changes from the backend, from the database. And then I need to just refresh my view if anything will change on this site and just apply all updates that will necessary after this change on the backend side. And now I want to show you my app that were created with Angular and this approach. So this app, this is Flight Manager. This app allows you to manage data of your flights in web app. And quite often, for example, we are on the airports where we don't have internet access. So it can be quite useful for you to be able just to add, to remember and check information about your flight. So we're able to see the list of your flights and add a new one. So you have to add some details. This is a short form that allows you to input data about a new flight. So we'll add, for example, flight number, your date for your flight time and arrival and departures, and some details. And if you add it, then you will be able see it in a list of your all flights. And this list is stored in PouchDB. And if you don't have internet access, then you will be able to have access still to this list. So let's open our developer tools. Let's check if our service worker is active, and if our manifest was added to my app. Yes, we can see this. We can also check the storages where it's stored. Here you can see the list of my flights that is stored in index database. And this is how it works. So now let's simulate the network change. So for example, you can select offline or slow connection and check how this app works. So I am still able to use this app. It's visible. My flights, and also add a new one because this new flight also will be added to PouchDB, to index database, to Pouch flights in index database. So I can do that again without the network or on slow connection. And if I will do that, I will check what happened in my developer tools. I can check once again my data in index database and also usages of my storages in general. So it offers you Chrome developer tools, and also you can follow what happens if you don't have this network access, and what, for example, how your network requests are replaced with other actions. So it was a short example with Angular, but you can also implement on your own for any other front-end solution, any other project For example, shopping list, because sometimes you don't have access to the network in shop, for example, so you can implement this app or just to test how this offline first works on your mobile in different network connections and in general. And now I want to tell you about the app shell model and what I told you before. This is crucial if we're talking about progressive web apps because it allows you to improve user experience. It can just deliver, minimize the first meaningful pain because your app don't need to initialize any JavaScript, can simply render HTML and CSS. And from practical perspective, this is a code, the minimal HTML, CSS, and JavaScript required to power user interface. And on the right side, you can see the example. This is skeleton, typically components of your app, quite often involved with navigation that are common to all pages. And now Angular allows you to generate the app shell with the only one command, ng-generate. So this process is really automated and it's really helpful for you, for developer. And if you use this command, you have to add two properties, two names. First is client project name, and the second, this is your universal project name. And here you can see the example. And if you run it, the most important change that you will see, you will get in Angular JSON file, and you will see a new two targets. And then you have to build this app shell. And here you can see examples for different environments, for local or for production. And I did a test and I implemented the same app that I presented you before with app shell and without. And I tested just from the user experience how it works. So here you can find how I refresh the same app 10 times with the app shell and without. And for app without the app shell, you can see the blank page, but for the app with app shell, you can't see any change. So we really delivered this first view to users so quickly. And it was just a visual effect, but let's take a look at more, let's say, technical results. So here you can see results of my performance tests. So it was for media run, and I ran it with web page test. And it will, here you can see the URL where you can find it. And I tested 5 metrics, the same for the same app, without the shell and with. And here you can find that for load time, first byte, start render, first contentful paint, and speed index, the results was over 20% better with the app shell than without. So this is what you can achieve with this model. And last but not least, I want to tell you and show you examples that were implemented with offline first, with PouchDB, not typically in Angular, but in general with JavaScript and with PouchDB. So it's my favorite. This is Hospital Run. This is open source app for developing word hospitals, and it allows you to store data locally even if you don't have internet access. So for example, in Africa, you can take this app into places where you don't have internet access at all. You can collect this data, and when you get back to the places with internet, for example, the hospital, then all your data are synchronized automatically with all clients. So it's open source, and you can find the source on GitHub. So I highly recommend you to read it and check it. And the second, this is Cozy Cloud. So this is personal cloud that can synchronize your contacts, calendar, files between your personal devices and servers. So you can store some data and share this data between your different clients. And another financier that also is similar, more for personal storing personal data like budgets. And these apps with offline first quite often inspired by native apps. So if we're looking for specific cases how to implement some features while we're offline, we should also inspire by native apps. And let's sum up some things. So today I told you about offline first approach. I told you about the golden rules, what are the advantages of this approach, and I highly recommend you to try it. Maybe you enjoy it, maybe it will be suitable for your project. And please remember that you don't need to use raw technical solutions for progressive web apps, but you have more developer-friendly solutions. For example, you have wrappers for index database. This is PouchDB or any other JavaScript libraries. And also remember that now framework supports progressive web features, so they allow you to easier create this technology. And last but not least, keep in mind that you're able to build fast and stable apps and to save the world from sadness. And that's all from my side. Thanks for having me, for your attention, and just have a good day. Thank you.